All right, welcome back. In this video, we're going to be dealing with inverse trig ratios. Now, we've already dealt with trig ratios, and we're still maybe sort of at the novice level at this point, okay? But we're going to go ahead and we're going to take a look at looking at trig ratios in the inverse, sort of the backwards version. So let's take a look at what we need to do with the calculator first. But on a side note, I am going to move pretty swiftly, so feel free to press pause at any point to catch up with me, okay? So I'm going to speak quickly just so that the video doesn't take a long time. It doesn't mean you have to work at the pace that I'm discussing things, right? Press pause and you take charge of how fast you go through this process. All right, let's move on. Now, as you know, we want to make sure that we're in degree mode in our calculator. We want to make sure that that degree is highlighted. So we're going to go and we're going to press the mode button that brings us to this screen and make sure that we are arrowed over and hit enter, right? If it's on radian, you want to arrow over degree and hit enter so that degree is highlighted, not radians. Okay. So once you make sure that you've established that your calculator's in degree mode, we want to start taking a look specifically at this little symbol here. And it looks like sine to the -1 power. And if you look closely at your calculator, in blue, you'll see sine to the -1, cosine to the -1, and tangent to the -1. And the way to get that function to come up in your calculator is first you're going to hit the second button, right? That's the first thing you're going to touch. And then the second one is you're going to hit the sine button. And then that'll bring this up on the screen with an open parenthesis. So we call this inverse sine, right? We also have inverse cosine and inverse tangent. So when I mention these words inverse, that's what we're talking about on the calculator. So this should go relatively smoothly. First, we want to start just like we did before. We're looking at the angle, and I'm looking at these two sides. I want to label them. This is the hypotenuse, and this is the opposite side. So this idea of opposite and hypotenuse, when we think about Sohcahtoa, right, we want to write this on every page still. If I think about opposite and hypotenuse, it looks like we're going to be dealing with the sine. So the sine of x degrees is equal to the opposite side over hypotenuse. So the sine of x degrees is equal to the opposite side is 15 and the hypotenuse is 24. And now you'll notice something new. In this version, we're going to be looking for angles, not side lengths. So instead of using angles and a side to find a side, we're using two sides to find an angle. So what do we need to do? All we need to do is to go into the calculator and work our way backwards. The calculator is going to do most of the work for us. And so here's what it looks like. We're going to say if the sine of x is equal to 15 over 24, then x is going to be equal to the inverse sine, that's sine to the -1, of 15 divided by 24. And we're going to go right into our calculator and punch that in exactly as I see it. So here's a little screenshot of the calculator, right? I said second sine to get that inverse sine, 15 divided by 24, enter, and I get 38.68. So x is equal to 38.7 degrees. And that's it, right? It says find the value of x, round to the nearest tenth, and I believe that we've done that. So number 1 is done. Number 2 is going to go very much the same way. I look at the angle and I identify the two sides. This is obviously the hypotenuse because it's opposite the right angle, and 8 is next to that angle, so that's my adjacent side. And I know that adjacent and hypotenuse is cosine. So cosine of x degrees is equal to 8 divided by 11. So if the cosine of 8 is equal to 8 divided by 11, then x is going to be equal to the inverse cosine of 8 over 11. And now I'm just going to go right to my calculator and have that do the rest of the work for me. And again, I go into my calculator and I'm going to press the second button. Then I'm going to press cosine. And when I press second followed by cosine, I should get this command. Inverse cosine of 8 divided by 11, as I stated right here. I hit enter right here. and I get 43.34. So x is 43.3 degrees rounded to the nearest tenth. So at this point, you should be saying, wow, this is fairly straightforward and easy. Yes, it is. Opposite the degree here, right, is our opposite side. And this is our adjacent side. And this is the hypotenuse, although we don't need to label it. It's nice to see all the players. So I have opposite and adjacent. Sounds a lot like tangent of x degrees, if you ask me, is equal to opposite over hypotenuse, or I'm sorry, opposite over adjacent, which is 20 over 37. So if that's the case, then x is going to be equal to the inverse tangent of 20 divided by 37. Right? And now I'm going to go guess where? Right to my calculator. So I'm going to go to second and tangent. And that brings me to inverse tangent on my calculator, 20 divided by 37, close parenthesis, enter. I get 28.39, which rounds up to 28.4. So x is equal to 28.4 degrees. And that's it. It's just about working slowly and carefully. So how do we set up these other versions, right? It's about labeling. So 18 is my adjacent side, 23 is my hypotenuse. So that sounds like cosine of x degrees is equal to adjacent over hypotenuse. So inverse cosine, right? X is going to be inverse cosine of 18 divided by 23. And then you go for the calculator and finish. All right, number 5, looks like we have the hypotenuse here, and then this is opposite the angle, right? So no adjacent sides here. So again, that sounds like sine of x degrees is going to be equal to my opposite side, 40 divided by my hypotenuse. So x is going to be my value of my inverse sine of 40 over 41. Okay, and then you're going to finish this one. The last setup here, looks like I got opposite side and adjacent side. So it looks like number 6 is going to be equal to the tangent of x degrees is equal to opposite, which is 7, divided by 5. So x should be equal to my inverse tangent of 7 divided by 5. Okay, and that's it. So why don't you go ahead and press pause and, finish all these problems. Okay, so you're going to finish 6, 4, and 5. Let's try that again. I missed it. 5. Now let's try a little review. Okay, so I said you were still sort of at the novice level. Now you'll notice that we have the angle here, so we're going to be finding sides. So this is the sort of forwards version, right? So this is not the inverse. This is this regular old sine, cosine, tangent. Same process. Looks like I have the adjacent side and the opposite side. So it looks like 7 is going to be the tangent of 39 degrees is equal to the opposite side, which is 11, over x. Now what? I'm going to go ahead and put this over 1. Cross multiply and solve. I'm going to get x times the tangent of 39 degrees is equal to 11 times 1, which is 11. Okay, then I'm going to divide by the tangent of 39 to isolate x, divide by the tangent of 39, and that cancels out, and I'm going to get x is equal to whatever the 11 divided by the tangent of 39 degrees is. And the rest is a calculator move. As you'll see here, the first thing I did was to identify what the tangent of 39 was, and then the next thing I did is I did 11 divided by, and I do second answer. Right? Press the second button and then the answer key. Where is that answer key? If you take a look, I'm pressing the second button right here, this blue button, and then answer is down here. Right? I'm going to press second and then answer, and that will bring the last calculated answer onto the screen for me. So when I do that, I have 11 divided by this last answer, which gives me 13.58 units, which is approximately 13.6 rounded to the nearest tenth. So the answer to number 7 is x equals 13.6. And that's a side length. So I'm not going to put degrees on that. Okay, again, a little more review. We have the angle, so we're not looking for an angle. We're not using inverse. We're using regular old sine, cosine, tangent. Who are these players? This is my hypotenuse. This is my adjacent side. Adjacent and hypotenuse. All right. Going back to Sohcahtoa. Haven't written this in a little while. All right. Sohcahtoa should be on every page, right? Write this on every page. Right. Label every problem, and you'll get more correct. And everybody's happy when they get things correct. So back to my problem. Looks like, smells like, cosine of 46 degrees is equal to my adjacent side, which is x, divided by my hypotenuse, which is 28. So I'm going to cross multiply and solve. And when I do, I'm going to get x times 1 is x, and 28 times the cosine of 46 degrees. So x is equal to, and the rest is a calculator keystroke. Again, as you'll notice, the first thing I do is move the screen. Let's try that again. The first thing I do is I calculate what the cosine of 46 is, right? It's 0.6946, yada, yada, yada. And then I just hit times. And what that does is it brings up ANS, the last calculated answer, times 28. Gives me 19.45. Because this is a 5, that's going to round to 19.5 to the nearest tenth. So x is equal to 19.5. And again, this is a side length. So it's not in degrees. It's just in regular units. Perhaps it was feet or inches or miles. And that, my friends, is number 8. To continue the setup here, I notice that this is my opposite side and this is my adjacent side. Opposite and adjacent, that's tangent of 51 degrees is equal to opposite, which is 8, and x, which is adjacent. So this is a multi-step algebra process, right? You're going to end up dividing in here, not multiplying. Okay, after you set up and cross multiply, you're going to have a few more steps, right? That's going to be x times the tangent of 51 degrees is equal to 8 times 1. Then divide both sides by the tangent of 51. Moving on to number 10, I have my opposite side and my hypotenuse, because that's opposite the right angle. Opposite and hypotenuse sounds like sine of 24 degrees is equal to opposite, which is x, over hypotenuse, which is 31. So this is the nice, easy version. When I set myself up for cross multiplication here, I'm going to get x times 1 is x is equal to 31 times the sine of 24 degrees. So go ahead and finish number 10. And number 9, I've already done number 7 and 8 pretty much all the way for you. So you're going to finish up 9 and 10. Now, what I'm going to do is I'll set these up and you finish. Okay, so I'll help you set them up and you knock them down after that. Looks like this first one, we're looking for the angle. So this is going to be an inverse trig, right? And it looks like number 12 is an inverse trig, and so are 13 and 14. So let's start labeling up. Opposite my right angle is my hypotenuse, and this looks like the adjacent side. So adjacent and hypotenuse sounds like cosine of x is equal to the adjacent side divided by the hypotenuse. Okay, so that's the first piece. If I'm looking for an angle, then if the cosine of x is equal to 14 over 22, then the inverse cosine of 14 over 22 will yield me my angle. Okay, and now you get the angle in question to the nearest tenth. Don't forget the degree mark because we're looking for angles. Number 12, right? Press pause if you need to, but press pause when you need a little bit of extra time to work. Okay. Number 12, opposite my x degree angle here is 25, so that's my opposite side. And this is the adjacent side, and the hypotenuse isn't labeled. So that sounds like tangent. So tangent of x is going to be equal to 25 over 78. Right? If you can't read the numbers, they're right here, which means that x is equal to the inverse tangent of 25 over 78. Okay, and now you finish that one. And again, don't forget to the nearest tenth and with degrees. We'll work our way backwards across the screen. Number 14. This looks like my opposite side, and this looks like the hypotenuse. And that's going to sound like sine of x is equal to the opposite side, which is 10, over the hypotenuse, which is 19. So if the sine of x is equal to 10 over 19, then x is going to be equal to the inverse sine of 10 over 19. And my calculator will help spit out the degrees to the nearest tenth. And lastly, we have the hypotenuse and adjacent. Right, so this is my hypotenuse because it's opposite the right angle. My adjacent side here, right, sounds like cosine of x is equal to the adjacent side over the hypotenuse, which is 31 over 36. So if that's the case, x is going to be equal to the inverse cosine of 31 over 36. And now you need to finish 11 through 14. All right, they're not done. So you finish those up. Continuing on to me helping you get started here, it looks like they want me to find DE. And so DE is way over here. And the problem is I don't know much about that triangle down at the bottom, so I'm going to need to do a little digging around on the upper triangle here. I'm going to call this the blue triangle. So this side would be helpful, the common side, and I know that I have this piece right here. So it looks like I got the opposite and the adjacent. So the tangent of 61 degrees is equal to the opposite, of which I don't know. I'm going to label that y, all over 24. Okay, and I'm going to leave DE as x. Now what? Let's go ahead and solve. Let's put this over 1, cross multiply. So 24 times the tangent of 61 degrees is going to be equal to y times 1, which is y. Okay, well, what is the tangent times 61 degrees? So I just do that right on my calculator, and I get that y is equal to 43.297, so we'll call it 43.3, right? And it's not in degrees, that's a side length. Now I turn around and I say, okay, well, I got this triangle, right? And I guess I'll make it in red. Right? I got this triangle right here. This is D, E, and F. And what did we just say? We said that this side was 43.3. And we're looking for this side, and I know that this is 19 degrees. So that is my opposite side. This is where the right angle is. So this is the adjacent side. So again, sounds like tangent of 19 degrees is equal to opposite, which is the thing I'm looking for, over 43.3. Cross multiply, looks like 43.3 times the tangent of 19 degrees is equal to whatever x is. So you finish and get an approximate value for x. That's a no-brainer. I've pretty much guided you all the way in. For number 16, very similar, only we're talking about finding angles. It says we want to know what the angle W is right here in sort of x degrees. So all we really need is the length of this side. Now, I'm going to call that side y, and I'm going to use this red triangle to find it. I have my opposite side, and this is going to be the hypotenuse for that triangle. So I'll say, well, opposite and hypotenuse sounds like sine, so the sine of 25 degrees is equal to 15 over y, right? I don't know what that is. Now what? Let's cross multiply and solve. So y times the sine of 25 degrees is equal to 15. Now we're going to divide by the sine of 25 degrees and divide by the sine of 25 degrees. Okay, and what do we get? Y is equal to, approximately I get to 35.49, which is approximately to the nearest tenth, 35.5. So that side is 35.5. And what are we talking about? We're talking about this blue triangle right here. So I'm just going to retrace that over here. So here's W, here's Z, and here's X. And I'm not going to draw the other triangle there. We're just going to say that this is 35.5. And we're looking for this angle right here, and I know that this side is 22. So let's label them up. Who are they? Well, this is the opposite side. This is where the right angle is, so obviously this is the hypotenuse, and this is going to be the adjacent side. So we're not using the hypotenuse, we're using the adjacent and the opposite. That sounds like tangent of x degrees is equal to the opposite side, which is 35.5, divided by 22. Okay, so now what? We're looking for that angle, so we're looking for inverse tangent, right? So x is going to be equal to the inverse tangent of what? Of this fraction, 35.5 over 22, which is equal to some angle in degrees to the nearest tenth. And again, I've pretty much guided you all the way in. You just got to wrap that up. Okay, so you finished numbers 15 and 16. That's your job. Okay, the last two problems are some word problems, really simple. All right, we have a ladder leaning against a wall again, so make yourself a wall, and then I guess go ahead and make yourself a ladder leaning up against the wall. Why? Because that's what they said we have, a ladder leaning against the wall. And it makes an angle of 75 degrees with the ground. Where's the ground? Well, I would think that the ground is down here. So it looks like this should be 75 degrees. Now, if we have an angle, I guess we're not using inverse trig. If the foot of the ladder is 6 feet from the base of the wall, so here's the foot of the ladder, here's the base of the wall, so it sounds like this is 6 feet. What is the length of the ladder? The length of the ladder is here, so go ahead and finish. Right? Give me a value for x, and remember this is not an angle, this is a side length. So we're not in degrees, okay? And the last one, Jaden is flying a kite, lets off 200 feet of kite string. So if we have a kite here, and I'm gonna do my best to draw a kite, right? There's a little tail, right? We got this kite string, right? And if you're flying a kite, right, we're down here. And if the kite is 150 feet above the ground, so let's say we got 150 feet above the ground, and 275 feet of kite string. So the 275 feet is the kite string. Above the ground refers to the vertical height of 150 feet. Okay. Assuming the string is straight, what angle does the string make with the ground? Technically the holder right here, right? So we got this idea of x degrees. So it sounds like this is going to be an inverse trig function. Okay, which one? And at the end, we should have x is equal to some degree measurement to the nearest tenth. All right, you figure out the rest, right? Be sure to label and solve. Good luck, and we'll see you next time.